Welcome to Das Chemistry. In this video, we are going to learn few question and answers from coordination compounds. Coordination compounds is one of the important chapter in grade 12, especially in the aspect of board examination. We get good marks from this particular unit. In this video, we are going to see few questions. At the start of the lesson, we have a topic, double salts. What is double salt? Double salt is a compound formed by a combination of two or more compounds. Double salt itself a compound. It is formed by two or more compounds. These compounds are stable in solid state and in solution they break into ions. Example, you see potash alum K2SO4, Al2SO4 thrice, 24H2O. This is potash alum, it is a double salt. Or simply it is known as alum. Here we can find potassium sulfate, aluminium sulfate. Double salt, two salts are there. Okay, these two salts are combined, two compounds are combined to form a single compound. In solid state, this compound is stable, but when this compound is added to water, it separates into ions or it ionizes. What are those ions? It turns into K plus, SO4 2 minus, Al3 plus. So we can find in this solution, we can find two metal ions, potassium and aluminium, two cations and an anion SO4. So in solid state it is stable and in solution it is not stable, it breaks into ions. So what is double salt? It is a compound formed by two or more compounds. It is stable in solid state, but in solution it breaks into ions. Then other examples are more salt. What is more salt? FAS, ferrous ammonium sulfate. Ferrous sulfate, FeSO4, ammonium sulfate, NH4 twice SO4 and 6H2O. And carnelites, KCl, MgCl2 dot 6H2O. Okay, next important question from coordination compound is Werner's theory. Explain Werner's coordination theory. In this theory, we will be learning about two things, primary valency and secondary valency. What is primary valency? It is the oxidation state of central metal ion or atom, right? The oxidation state of central metal atom, and it is ionizable. Non-directional and ionizable, and this primary valency is equal to the oxidation state of the central metal ion. And secondary valency. What is secondary valency? This is directional and non-ionizable, just opposite, and it is equal to the coordination number. It is equal to coordination number. For example, CONH3 6 times, Cl3 out of the coordination box. You see, this can be separated. When we separate this, the chlorine gets minus 1 charge. There are 3 chlorine atoms and it is minus 3. Total charge is minus 3. If this is minus 3 total charge and this will be plus 3. Let us check. Cobalt, let us keep X, and for amine, for this ammonium or amine ligand, the oxidation number is 0. It is equal to plus 3. So X is equal to plus 3. This is what called primary valency, the oxidation number. This cobalt gets the oxidation number of plus 3. And what is the secondary valency? These 6 ligands are attached to cobalt. So the coordination number is 6. So very simply we can define or explain Werner's theory, primary valency and secondary valency. And the third question, what are homoleptic complex? What are homoleptic complex? We know that a complex contains central metal atom and the ligands are attached to it. Okay. Sometimes different kinds of ligands may be attached. Those complexes are called heteroleptic complex. But in homoleptic complex, the central metal atom is attached to only one kind of ligand. See here, the central metal atom is attached to only one type of ligands. Okay. So these complexes are called homoleptic complexes. Complex in which a metal is bound to only one kind of ligand. The central metal atom is attached with only one kind of ligand. And the fourth question is, differentiate between inner orbital complex and outer orbital complex. What is inner orbital complex? The octahedral complex in which the inner d orbital, that means n minus 1 d orbital is involved, okay, in coordination. Then if inner orbital is involved, mostly pairing of electron will take place. So it is also known as low spin complex. And they may have very less unpaired electrons. Sometimes there will be less or no unpaired electrons. Example, CO, CN6, 3 minus. Next, outer orbital complex. What are outer orbital complex? It involves outer d orbital. Outer d orbital, that means n d orbitals involved. Then just opposite of that, here low spin, that means here high spin. It is also known as high spin complex, and it will have large number of unpaired electrons. I hope you understood these 4 questions. In the next video, I will explain how to name coordination compounds by the IUPAC system. Thank you for watching. Subscribe my channel and share with others. Comment the topics which you want to learn. Thank you.